And good afternoon, ladies and gentlemen. This is Michael Johnson coming to you live from the Coca-Cola Space Science Center studios north here. And with me, I have Dr. Rosa Williams, who is our astronomer extraordinaire there. She is actually in the observatory right now. Is that right, Dr. Williams?
That's right. I'm up here sweltering in the observatory with the telescope pointed at the sun.
And of course, today we want to show you the sun live from our solar telescopes here. But if you take a look right above Dr. Williams, you'll see our latest weather and clouds coming to us from the GOES satellite deep in space. And if you kind of notice right where we are, which is, let me point this out to you, right about there, if you can see my pointer, we have clouds. And of course, that's going to happen whenever we want to show anything live with the telescope. So, but we have had breaks in the clouds, and we have been able to see it. So we're going to talk a little bit about the sun. And Dr. Williams is going to keep an eye out. I'm going to keep an eye out. And if we see the sun pop out, we'll go ahead and go immediately straight to the live sun. But first, what we want to do is let's talk a little bit about the sun itself. And what I want to do here is go ahead and it always works until you want it to, right?
Well,
Go
I'll
ahead.
start off
Yeah, go
by
ahead.
talking about the solar disk, which our sun is immense compared to the Earth. You could fit 110 Earths side by side across the disk of the sun. We'll talk about activity on the sun, the stuff what we're usually looking for, like a sunspot. Well, your average sunspot is just one of those 110 little Earth disks across. So if you put the Earth right up next to the sun, which I don't advise, then you would have something roughly the size of a medium sized sunspot.
And I'm going to have to apologize to everyone. Right now, my software, which is streaming, is stuck. It does not want me to do anything.
So I'll talk a little bit more about the sun while that's getting restarted. So one of the reasons that we are constantly monitoring the sun is because, as you can see from the posters behind me, it undergoes all kinds of solar activity. And that solar activity has a non-zero chance of affecting us here on Earth. So for instance, just yesterday, we had a geomagnetic storm here on Earth. That sounds pretty impressive, right? What that means is the flow of activity from the sun, the solar wind, which intensifies anytime there's strong solar activity, that activity has actually swept all the way to the Earth and is interacting with Earth's magnetic field. One of the things that we look for, this was a very minor solar event, so you get to see auroras, the northern lights and the southern lights. So if you were at high latitudes up by the Arctic, you got to see shimmering lights in the sky yesterday due to this activity on the sun. But it can actually affect us in much greater ways. So when you have significant solar activity causing these geomagnetic storms, it can do things like knock out sensitive satellite instruments, disrupt radio communications, actually disrupt power grids and cause massive outages. So this is one of the primary reasons that we spend so much time with our telescopes trained on the sun. It's because it does affect our life here on Earth, especially in these modern technological days. So back in 1859, we were not quite as technologically developed back then. We had telegraphs, which were long strings of wires stretched across large amounts of distances. So it's kind of like our modern power network, but on a much smaller scale. They were run by power sources, batteries basically, hooked up to the telegraphs, and they moved by sending small electrical signals. Well, one day on the sun, a scientist, Dr. Carrington, noticed a major eruption, what we'd call a major solar flare and coronal mass ejection coming off of the sun. A couple of days later, it hit here at the Earth, and so much energy was thrown into Earth's magnetic field that it created electric fields all throughout the telegraph grids. Those electric fields surged through the wires. For a little while, you could operate the telegraph with the little key without having to worry about connecting it to the battery. There was so much power already in the wires that it was working. But I wouldn't advise doing that because a lot of telegraph operators who touched those metal keys got a nasty shock, and I mean that literally. I mean, there was so much power running through the wires. In some cases, it caused actual fires to break out in the telegraph offices. Wow, we now know that as the Carrington event, and it's the sort of thing that we really worry about these days, not because it's going to, seriously harm us physically, but because our technology is so sensitive to radio and electrical disruptions that this kind of event, if it ever happened here on Earth, might cause some serious outages at a pretty widespread level. We only have a certain number of power transformers, for instance, to run our power grid off of. Well, in 1989, a relatively moderate solar event surged off of the sun and smacked into Earth's magnetic field. The resulting surge went through a transformer in Quebec. It was a nice, shiny, brand new piece of equipment meant to power the entire province of Quebec, and it was burned out in seconds. The power surge that was created by this event went through the power grid all across North America, causing all sorts of blackouts and brownouts. Now, we've done what we call trying to harden the power grid. That is, put in a whole bunch of switches and circuit breakers so that if there's a power surge like that, it will not spread beyond the local area. That said, if there's a surge big enough to affect more than one transmitter, those things are very hard to obtain, and we only have a couple of spares at any given time.
All right, Dr. Williams, I see glimpses of the sun coming in and out.
That's right.
Unfortunately, what I'm going to have to do is I am going to have to physically disconnect and reconnect. My software has just decided that it didn't want to go any further. And of course, it's impossible. Whenever you want to show something in this live from an observatory, something has to happen. So, ladies and gentlemen that are watching, please forgive me while I go ahead and disconnect from this, and I will reconnect in just a few moments.